Alright, so let's take a look at number 11. Number 11 said we have negative 3/10 minus 5 over 100. Is this the one you're talking about, sweetie? Okay. My initial comment for you, to all of you, is don't lose those negative signs. Alright, my other comment to you, and Christiane, you had said this yesterday about this, when you have a negative already and then you have subtraction, this is when I would definitely do adding the opposite, for sure. Alright, so Mia, first of all, I have a 10 and I have a 100. So all I need to do is change that one fraction because my common denominator would be 100. So off to the side, I'm going to change 3/10 by multiplying by 10 over 10, and that's going to give me 30 over 100. Are you cool with that? Okay. When I come back and rewrite this, it's negative 30 over 100. You guys put the negative on the numerator. It makes more sense. I mean, technically it can be in the denominator, but that's when things get a little confusing. Alright, so whenever you have a negative fraction, but just put the negative on the numerator. Alright, minus 5/100ths. I'm immediately here going to do adding the opposite. Because what I find becomes a problem is, when we have a negative 30 minus 5, someone's going to say this is a negative 25. Alright, but it's really not, if we change this to adding the opposite, we can actually see we have a negative 30 plus a negative 5. So be careful with that subtraction. For us to have that be 25, this would have to be a negative 30 minus 5. That would give me a 25. Alright, so pay attention to adding the opposite here. The moment I do that, we realize, oh, okay, I actually have to add those. So it's a negative 35 over 100. I can divide out common factors here. They have common factor of 5. So that negative 35, God bless you, becomes a negative 7. That positive 100 becomes a 20. So my final answer is negative 7 over 20, and I hope that's what they told us. Does that help you, sweetie? Awesome. Mateo. 10? Yep. God bless you. So number 10 said I have 12 over 20 minus 1/4. Is this the one you're talking about? Okay, so this is why I want you giving yourself room. Because I want your corrections next to the original problem so you can kind of compare the corrections to what you did. That's my goal. So always give yourself space when you're doing your homework for corrections. Alright, so I can use 20 as my denominator. So I'm going to multiply 1/4 by 5 over 5 because 4 times 5 gives me my 20. So this is 5/20ths. Now Mateo, I'm going to come back and I'm just going to rewrite the problem with that new fraction. So I have 12/20ths minus 5/20ths. This is direct subtraction. I mean, this is the bigger minus the smaller already. So I can do adding the opposite here if I want. I don't have to. If you like just being in the habit of doing adding the opposite all the time, then go ahead and do that. Alright, 12 plus a negative 5, or 12 minus 5, is 7. So that's 7/20ths. Do you see the mistake that you made? I don't know. Because you added 12 and 5 and not subtracted. That's what you did. What else can I do for you guys? Kira? Number 6? Awesome. So 6 is 7/8 plus 5/8. Well, this already has a common denominator, so all I have to do is add my numerators. 7 plus 5 is 12/8. Generally, improper fractions, we want to change them into mixed numbers. If you didn't, this is your improper fraction. But to change it into a mixed number, I need to do that division. Right? So I can do it actually in my head right here. How many times is 8 divided into 12? How many times is 8 divided into 12? Once. So my whole number is a 1. What is 12 minus 8? So that 4 is my numerator. So I have 1 and 4/8, but 4/8 is the same thing as a half. So 1 and 1/2. But if you can't do that in your head, then I expect to see 12 divided by 8. That divides into it once. 12 minus 8 is 4. That now becomes, that remainder is now my numerator. So this is 4/8. So if you can do that in your head, awesome. If you can't do that, make sure you do the division. Layla. 28? Yep. All right, so 28 said 12/15 plus 1/2. Is this the one you're talking about? Okay. I'm just going to multiply those two numbers together. 15 times 2 is 30. All right, I'm hoping that jumped out at you as 30 is your common denominator anyway. But if it didn't, you know, that's one way to get it. So I'm going to multiply 12/15 by 2 over 2, and that gives me 24/30. I'm going to multiply 1/2 by 15 over 15, and I get 15/30. I'm going to come back and rewrite that, so I have 24/30 plus 15/30, and that's going to give me 39/30, and then I'm going to change that into a mixed number. All right, 30 divides into 39 once. There are 9 left over, so that's 1 and 9/30. 3 divides into both of those, so that 9 becomes a 3, the 30 becomes a 10. So this is 1 and 3/10. Oh, okay. What else can I do for you guys? Mateo. 12. All right, so if there were some that gave you troubles last night, I would recommend you grab one of them and redo it tonight for homework on your own. All right, that's a good way to reinforce and see if you understood what you were doing, particularly 12 here. Any of them with variables in them, I would redo. All right, so I have 6x minus 2/5. So Mateo, what common denominator am I going to use? Yep, I'm going to multiply 5 times x and get my common denominator. So Mateo, what do I have to multiply 6 over x by? 5 over 5, excellent. So I get 30. Everyone's looking at 12, making sure you have the right work. If you don't have the right work, you're correcting the work. That's the most important part, is your understanding of how to do it. All right, Mateo, what am I going to multiply 2/5 by? Yep, x over x, so I get 2x over 5x. So I'm going to come back over here. I have 30 over 5x minus 2x over 5x. So Mateo, now I just need to add those numerators. What am I going to write for my numerator? Right. Excellent. That's exactly right. I'm just going to leave it alone just like that. Frankie. I did. You could have left it as 30 minus 2x. That's fine with me. But he did adding the opposite, and that doesn't bother me. In the book, they probably have minus 2x, and that's the same thing. All right, put this away, get your notes out. We're going to talk about mixed numbers. We're going to talk about mixed numbers. Can you believe we're halfway through February? More than halfway through February. We only have 9 days left of February. Because this year we have a February 29th, don't we? Every 4 years? I'm pretty sure this year we have one. My sister was born on the 29th. So she doesn't have a birthday every 4 years. She has an actual birthday. She'll be 52, but she was born in 68, so what would that make her? Divide that by 4. Yep. No. What, no? So how many years has it been since 68? So she'd be 17, 16? That's how old she'd be. Okay. So we are still in 5.3. So 5.3 continued. Today we're going to be talking about adding and subtracting mixed numbers. Now, you guys, this is when you're going to be like, oh no, we can't. That's what you're going to say to me. All right? This is my rule. This is not you never can. This is a Mrs. Carter won't let me, or Mrs. Carter requires. All right? I require you leave all mixed numbers as mixed numbers. You may not change them into proper fractions for me. I want you guys being really proficient in using mixed numbers and adding and subtracting. All right, improper fractions is too easy. So it's really important that you guys be able to deal with mixed numbers, okay? So here is my statement. You may not change mixed numbers to improper fractions. I am challenging you guys to be awesome at math. All right, I just need you guys to understand how mixed numbers work. Okay, I'm going to start with the story problem, because why not? All right, and then I'm going to talk about subtraction, because subtraction is the hardest one. So I'm going to start with something a little bit easier. All right, so here's my example that I want you guys to do. I'm going to show this to you. I want you guys to write down the problem, and then we're going to write a game plan for it. We're going to write a game plan for this, and then we're going to do the math. So somebody read that for us. Somebody read that for me. Come on. Christiana, thank you. Shasta. Okay, so write down your givens. Let's come up with a game plan, and then we're going to go ahead and do this math together. So here is the givens as I see them. I just bullet pointed them. All right, so we hiked 2 2/3 miles. Then we hiked another 1 3/4 miles. I want to know how many miles in all. Somebody write a game plan here for me on this. Jack? Okay. Nope, no numbers. So maybe like the initial miles, right? Okay, so I'm going to write something like initial miles. Okay. So am I adding them? Plus the miles more, or miles to campsite. Does that make sense? Equals what? Yep, equals total miles hiked. How many of you guys agree with the game plan? Excellent. Put your numbers in for me, Jack. Okay. And what I don't know is a total, so I'm going to put X there. Equals X. All right. How many of you guys are cool so far? Okay. This is a requirement of mine. So let me ask you guys something. If I gave you this, what would you do first? Would you leave it like this? What would you do? Aaron, what would you do? guys agree that you would line this up vertically? Absolutely. Makes sense, doesn't it? Because I add my ones, then I add my tens, then I add my hundreds, etc. This is the same philosophy I want you using for mixed numbers. I want you lining them up vertically. So what I'm going to do here is I'm going to line this addition up vertically. That is a requirement of mine. Again, you guys, I'm just setting you guys up for success. All right, so I'm going to go ahead and do 2 2/3 plus 1 3/4. So I'm going to line it up vertically. What work do I now have to do to be able to do this addition? What work do I have to do? Aaron? They do. They need a common denominator. What common denominator do you want to use? 12, sure. All right, so I'm just going to show it right here. If you want to do it off to the side, you can. I'm going to go ahead and do it here. So I'm going to multiply 2/3 by 4/4, and I end up with 4 8/12. I'm going to multiply, what am I going to multiply 3/4 by? To get my equivalent fraction with a denominator of 12. Alex? Excellent, 3/3. So I end up with, I'm going to add 1 9/12. Now I'm going to go ahead and add. So I have 17/12. 1 plus 2 is 3. Am I done? Here, am I done? Why? It is. So I need to take this improper fraction and I need to make it into a mixed number. How many times is 12 divided into 17? So I'm going to teach you guys to do this right here. How many times is 12 divided into 17? Frankie? Once. What is 12 minus, or 17 minus 12? So that becomes my numerator, 5/12. And I'm just going to add that back onto the 3. So my final answer is 4 5/12. If you can't do that 7/12 as a mixed number in your head, just do the math off to the side. That is so fine with me. Divides into it once, and there's my numerator. How many of you guys are cool with this? All right, let's do a couple more of these. I'm going to talk about subtraction now. I figure the addition is the easiest. So let's talk about subtraction. Okay, if I gave you this problem, 3,551 minus 27. You don't have to write this down, I just want you to look at this. If I have to do this math, what's the first thing I need to do this subtraction? Please listen to me. What's the first thing I need to do this subtraction? This is 3,551 minus 27. What's the first thing I need to do this subtraction? Addison? Exactly. When I make that 111, what am I actually doing with that 1 that I'm borrowing from the 5? What is that 1 actually? So when I borrow a 1 from that 5, what am I actually borrowing? Alex? I'm actually borrowing a 10. When I make this 1 and 11, what am I actually doing with that 1? Kira? I'm adding it a 10. So I'm actually doing 10 plus 1, which gives me my 11. How many of you guys know that that is actually what we're doing? Okay, so I want you guys to keep that in mind when I show you subtraction, because in some instances we are going to have to borrow. All right, so let's do this one. Let's do 3 1/3. I'm just going to do this with the same denominator so I can focus just on the borrowing part. Okay, minus 1 2/3. All right, I'm going to go ahead and line this up vertically. The mistake somebody is going to make, somebody's going to go in the direction of the 2/3 minus the 1/3. They're going to start with the lower one and subtract off the upper one. they're going to get 1/3, and then they're going to do 3 minus 1 and get 2. Can you guys see how that's wrong? You always subtract the upper one minus the lower one. So what we are going to have to do here, we're going to start with that fraction like we always have to. We always start with that far right. And here we have to borrow. So what we're going to do is we're going to take that 3, we're going to make it a 2. And what we're going to do is we're going to add a 1 to the 1/3. For me to add, so what we're going to do is I want to add a 1 to the 1/3. What does my 1 have to look like if I'm adding it to 1/3? What does my 1 have to look like for me to add it to 1/3? Layla? Not 1/1. Don't we need to have a common 1/3 is 1/3. Not a 1. What does 1 look like if I have to have 3 as my denominator? Angela? 3/3. So I'm going to add 3/3 to my 1/3. 3/3 is 1, isn't it? How many of you guys agree that 3/3 is 1? So that 1, we have to use a 3/3 because our denominator is 3. How many of you guys understand that? Okay, so now I'm going to rewrite this. So I have 2 4/3 minus 1 2/3. Now I can do that subtraction. What is 4/3 minus 2/3? What's 4/3 minus 2/3? Mia? 2/3. What's 2 minus 1? Mia? 1. There's our answer. All right, let me give you guys another one to do like that, okay? So here's my example. I want you guys to simplify. Let's do 3 1/6 minus 5 2/3. So 3 1/6 minus 5 2/3. Okay. When we do this, remember, we need to do adding the opposite. How many of you guys agree I need to do adding the opposite here? So I'm going to go ahead and do adding the opposite. So I'm actually adding 2 numbers with different signs. So if I'm adding 2 numbers with different signs, I'm actually subtracting them. How many of you guys agree with that? Okay. So when I'm subtracting numbers, which number, if I'm adding 2 numbers with different signs, which number has to go on the top in my subtraction? All right, so let's think about this in a different one. If I have 5 minus 10, what math, which is the same thing as 5 plus a negative 10, what is the subtraction I'm actually doing? So I want to do one that makes sense to you already. What is the actual subtraction that I am doing? Frankie? No. This already says negative 10 minus 5. This is the same thing as 5 plus a negative 10. What math am I actually doing? Because negative 10 minus 5, this is actually negative 10 plus a negative 5. So those aren't the same thing. What math am I actually doing? Vincent? Be specific. So 10 minus 5, correct? So isn't this the same thing as 10 minus 5? How many of you guys agree that this is the math you're actually doing? When I do that, I get 5. However, what is the sign of my answer? Romano, you're paying attention to what I'm doing. What is the sign of my answer? Remember, when you're adding 2 numbers with different signs, you're actually subtracting their absolute values. So what is the sign of my answer? Angela? Negative, because the 10 was the greater absolute value, was negative. I want you guys thinking about this example as we set this up. So if I take a look at our work, 3 and 1/6 plus a negative 5 and 2/3. What is the subtraction I'm actually doing? Remember, we subtract their absolute values. So what is the subtraction I'm actually doing? Remember, I dropped the requirement to show the absolute value. Christiana? Yes. I'm doing the greater absolute value minus the smaller absolute value. All right, so here we have the greater absolute value minus the smaller absolute value, which is exactly what we do when we have integers. Okay, now we need to do equivalent fraction work, correct? How many of you guys agree we need to do equivalent fraction work? Okay, what am I going to do? 1/6 I'm good with. What am I going to do to have an equivalent fraction? Alex, multiply by 2 over 2, and I end up with 5 and 4/2 6 minus 3 and 1/6. Do I need to do any borrowing work here? Do I need to do any borrowing work? And why or why not? Mia? Yeah, here I don't, there's no borrowing needed. So I can go ahead and just do that subtraction. 4 minus 1 is 5, so that's 5/6. 5 minus 3 is 2. Is that going to be a positive 2 and 5/6 or a negative 2 and 5/6? Christiana? Negative, because that 5 had the greater absolute value and it was negative. Can you guys see when you have to borrow and when you don't? Layla? I did oh my goodness, thank you. I'm so happy you guys are catching me in my mistakes. This should be a 3. Thank you, Layla. That should be a 3. You're right, that needs to be subtracted, which turns into a 1/2. So that's negative 2 and 1/2. Thank you so much for catching my mistake. Frankie. So if you notice here, when I taught you with integers, remember we do the absolute value work. This is the absolute value of negative 10 is equal to 10. The absolute value of 5 equals 5. And we subtract their absolute values. Do you agree with that? I'm doing the same thing here. So because I'm just subtracting the absolute value of negative 5 and 2/3 minus the absolute value of 3 and 1/6, the negative with that 5 doesn't come with that subtraction because I'm subtracting their absolute values. So this is going back to our same subtracting or adding integers with different signs, that absolute value work. I'm doing the same thing here. All right, so that negative gets picked up, Frankie, at the end in our answer. Just like here, the negative got picked up once we figured out, okay, we did the bigger absolute value minus the smaller absolute value. We got the 5. So 5 plus a negative 10 is 5, but now we've got to be like, okay, is it positive or negative? That function and process is exactly the same thing I did here. Now I just have fractions with it. Does that make sense? Okay, Christiana. I added 2/3 to 1/3. When did I add 2/3 to 1/3? Right here? Well, that's because it was addition. Because I was adding these fractions together. So the first example was actually adding the fractions. The second 2 examples was subtracting the fractions. Can you see that? Does that help you? All right, so you have an example of adding mixed numbers. You have 2 examples of subtracting mixed numbers. One of them is when you need to borrow, when the upper, the top fraction is smaller than the lower fraction. The second one is when you don't need to borrow. The top fraction is bigger than the lower fraction. All right, so pay attention to these. you're gonna have tonight's homework with this, and then tomorrow night we're gonna do more of this so you guys can reinforce it. You guys cool? Okay, you guys can go.